Hey friends, we are going through your test 2 for physics, of course. So here's our physics 102. Physics 102 test 2. Okay. We want to quickly just look at the we're going through the things that you're going to need to answer this test. Okay. Now what you're going to need is, first of all, I'm just going to put the formulas. And with these formulas, we're not even going to think, we're not even going to try and read a huge part of the question or do all that. We're just going to be answering questions as fast as we can, okay? Now, the only thing that we would need to then know how to really do is like the KVL and the KCL and whatever. But everything else, these formulas that we're going to do are going to be important. So I want you to do this. The moment you get into an exam, into your exam, go to the back of the paper or wherever you see some free space, and with your pencil, write down all these formulas. These are going to be so useful for you as you answer the test. So let me do it. These formulas, we're going to split them into the formulas for week 5 and 6. Then we're going to put the formulas for week 7. So the formulas for week 7, we'll put them on their own here. Now let's quickly start going through the formulas and let's see the formulas that you're going to need to know. It's not too much, okay? So for the formulas, we start with week 5 and 6. We'll be starting with the common things, the terms that you already know. We put all of them, then we put the remaining ones. So it's going to be current. We start with the current, and current has 3 formulas to put. So you're going to put the 3 formulas for current. This one, we are starting, the first one starts from saying current is equal to never, okay? And this V is a VD to mean drift velocity. N is called number density. E is the charge of an electron. V is the drift velocity, and A is the area. But then in your slides, you won't see it as never. Although 90% of the problems you do, you'll be using E, okay, which is the charge of an electron. But for you, in your slides, you're going to see it being NQ, then VD times area. Because they're going to put the charge of anything, not just an electron. And the charge of an electron is included. So the charge of an electron is also Q. Okay, Q represents charge, not just of an electron, of anything. Then if you know this one, you're going to know the second one, which says current is the rate of flow of charge, which is delta Q over delta T. This is going to be the second one you're going to use. Then the third and final one is going to be current is going to be, now this is for orbiting electrons that are going around in circles. It's going to be the velocity of the electron, which will be the linear velocity. Like we have an electron going around in circles like this, right? This will be the V, the velocity, and that is the one we put here. And we multiply by the charge, but put the charge in modular signs. We don't want it to be positive and not to be negative. Then divided by 2 pi r, okay? And you'll be having the radius of, this is going to be the radius of the rotation of that electron. So this is going to be something very important. And here is the third and final formula. I know you haven't seen it before, so put emphasis on it. Make sure you remember it. VE over 2 pi r. But the E should be in modular signs. Remember that E is representing the charge, as the charge of an electron. Now, before we go to the other formulas, we must just put 2 more things that you must not forget is what is the formula for N and the formula for A. So the formula for N is the number density. We can say that N is equal to Avogadro's number, which is going to be NA. That's Avogadro's constant. Then we multiply by the charge again. But then now we are going to, instead of dividing by 2 pi r, now we're going to divide by M, which is molar mass. Okay, we divide by the molar mass, the mass of 1 mole. You see on your periodic table, whatever you're dealing with. This gives you N, the number density, which is going to be number of things per cubic meter. It's going to be number of things per cubic meter. You see that. And then we have A, which is going to be the area, and area is going to be pi r squared. It's going to be the area. You'll be dealing with like a wire most of the time, and you'll be talking about the area, and the area particularly of this circle here. Okay, the cross section, which is the face of your pipe, which is going to be or your wire, which is going to be the circle, and area will be pi r squared. Sometimes you get diameter, and you still get area from that. It's going to be diameter over 2, then O squared. So it's pi diameter over 2 O squared, because diameter over 2 gives you radius again. So here is the thing. Now we go from I. We have put these 2 things that you saw in never. And the formula for NQV in VD. VD is just drift velocity. And we must put again another formula for that guy. Brings me to that. Drift velocity is just going to be equal to, we say that the drift velocity, another formula for it, is going to be the length over the time, which is distance over time. It's velocity, right? It's distance over time taken. So it's going to be the length of the wire divided by how long it takes to move across that length. So this gives us drift velocity. And when we have this, now we can go to the other things, okay? Now let's go. What are the other things to then put? So we have seen that in this formula for I is equal to never, please remember to put the formula for N, for VD, and for area. Okay? Then from here, after putting the 3 formulas for current, 3, then we're going to put the 2 formulas for resistance, which is going to be, first one says resistance R is equal to rho L over A. This is the first formula for resistance. Then the second and final one says that resistance R is equal to initial resistance R0. Then you open a square bracket, you say 1 plus alpha. Alpha is going to be the temperature coefficient, the coefficient of temperature. Then we say, in brackets here, we say T minus T0. Just like here we had R, then R0 on the other side of the equal sign. Here it will be T, but instead of going on the other side of the equal sign, it will be minus. So T will come before T0, just like R came before R0. So it'll be T minus T0, and you put this in square brackets. And this gives us the second formula for resistance. So we have resistance is rho L over A. Then we have resistance is R0, 1 plus alpha T minus T0. This is going to be the second one. Then from there, now what do we go to? We keep moving. From here, we have this I, we have R. Then we're going to have 1 for V. Delta V is IR. This is going to be the Ohm's law. Remember this one. We're going to need it, okay? And you're going to see something we're going to do with it when we go to the week 7 formulas. So there is 3 for current, 2 for resistance, 1 for delta V. But remember that in VD and A, in the 3 for current, you can have some formulas for those. So 3 for current, 2 for R, 1 for delta V. And then we also have formulas for this delta N, this VD, the drift velocity, and this A for area, okay? Now, when we have done this, are we done with the common things? No. We then go to charge, which is delta Q. This is for total charge. It is going to be equal to, sometimes we can just say Q. It is going to be, but sometimes we can say delta Q. Delta Q is equal to delta N, which is the total number of particles, times E, which is the charge on 1 electron. So thus give you the total charge. Total number of electrons times the charge. So this is delta N is actually the number of charged particles, and usually it will be electrons, okay? This gives us here the total charge. Then we know that E is going to be the charge on 1 electron, which this E you find in front on your paper. So now this delta N. Now, what we will never do is write 2 versions of the same formula. Like to come and say to you, there's another formula which you may see in your slides, which is now for delta N, which you say delta N is equal to delta Q over E. It's just this formula. We are just going to rearrange this one, so we don't need to cram another one like that. But what you must know is when you are then finding the number of particles, this delta N, if delta Q is positive, then you are going to have to put E in modular signs, okay? Because the number of particles should come out as a positive answer. So if the top is positive, the bottom must be positive. And E is the charge of an electron. We know it is negative 1.6 times 10 to the negative 23. So we would need to make this positive by putting modulus on it, just like we did here, and it will come out as a positive thing. So anyway, that gives us the thing. So for delta N, remember, you may have to do that. Now that I have this, let me choose with squared. So I have 3 for current, 2 for resistance, 1 for delta V, 1 for delta Q, okay? And you should also know that delta Q is also found in here. So if in case you're looking for delta Q, you can also come to this one. Oh, are we done? No, we are not yet done, my friend. We're not yet done. So what are we going to add now? What are we going to add? We are now going to add the formula for J, which J is going to be called current density. Current density is going to be current over area. This gives you current density, but it should be current in modular signs. So it's going to be current or over area, but the current should be in modular signs. And this gives us the J, which is going to be current density. So please put that, don't forget. Now the other one is going to be J is going to be sigma, which is now conductivity, times E. This you should know. This is going to give us again J. This is going to be our current density again, but this sigma, you haven't seen it. This is going to be for conductivity. So it's going to be conductivity, okay? Now I want you to know that even though I've put this E, usually we put it like this. It's for electric field. Okay, it's not for EMF. You're going to see EMF in week 7. So I should make sure I emphasize that. This is for electric field. And now we have the thing. J is still the current density. Don't forget. This is still J for current density. Now we have the 2 for current density. Now we are going to have the relationship between this guy called conductivity and resistivity. Remember, this rho was resistivity. And when we come here, we are now going to say that resistivity rho is equal to 1 over conductivity, sigma, which also we can say that conductivity sigma is equal to 1 over resistivity. Okay, it's the same thing. So you should know that if resistivity is 1 over conductivity, then conductivity will be 1 over resistivity. So if you do part A and you get resistivity, then they ask for conductivity. We know that conductivity will be 1 over resistivity. If they ask for resistivity and you have conductivity, you know that resistivity is 1 over conductivity. So this is going to be resistivity. It is the inverse of conductivity. Okay? This is the other thing to know. Do not forget it. So now we have this relationship between resistivity and conductivity as well. Okay? And the last thing, you are almost done. The last thing is going to be now the 5 ways to get power. Let's do them. 5, yeah. It's actually, for the other one, it's just, it's not that, it's not, we cannot really say it's just a formula, but it's a little bit of common sense, but yes, we'll still put it as a formula. First one is P is delta VI, delta V times I, or P is VI. Sometimes you see it like that. Or we can say it's delta V times I. Then again, P is equal to delta V O squared O over R. Okay? Don't forget that. Then we have P is equal to I squared R. This is going to be power loss. This will give you the power dissipated, okay, or power lost. So power dissipated. There we go. We use this one. Usually for power delivered, we use this one. This will be our power delivered. All right? Now, this is the power delivered, delta V squared over R. Now, we have these 3. Then what else do we have? The fourth one is power is energy over time. Okay? And this, you are going to use it a lot when we are calculating the cost of electricity. We'll make energy the subject, then of course we multiply it by the cost, which we'll see how. So power is the rate of energy conversion. How fast you can convert energy from one form to another. So it's going to be energy over time, which is the rate of doing what? Converting energy from one form to another. So power is energy over time. This is the fourth one. Then just the final one is going to be the total power when you have bulbs. The total power is going to be the power rating on one bulb times the number of bulbs. This will give you the total power in the whole thing. Okay, let's say you have several bulbs. This is how you get the total power. And this will lead us to the final formula, and we'll be done with the formulas. We will get to apply them now in the next one. But first of all, we need to talk about the ones for week 7. So please make sure you can write these formulas as I have. Okay, 3 for current. Then these 3 things in the never. Current is NQ VDA. You put them like the N, the VD, and the A. Remember, the N is going to be, this is Avogadro. This is going to be Avogadro's number. Okay, and this one should be in modulus again, I think. Then this is the charge of an electron. Then this is going to be the molar mass. Okay, this is going to be the molar mass. So don't forget these terms, and you're going to find M, the number density. That is what you need. And this will bring us to the end. Now we are just going to then go to week 7. This is not a lot. This is the test we have to ace. And you're going to see, as even I try to, I'm going to solve a lot of tutorial problems for you and show you how you actually then solve a problem in the exam. Not, you don't read it. You skim through it and you apply the formulas, and the formulas will find the answer for themselves. You don't have to try to think. No reason to think. Okay? That's it. We'll meet in the next one when we talk about week 7 formulas. Goodbye for now.